In this video, we're going to talk about colligative properties. These are properties of solution that are dependent only on the concentration of the particles in the solution, and you may be familiar with some of these. So, some properties of solutions depend only on the concentration of the particles in solution. They don't depend on what those particles are, and those are called colligative properties. We're going to focus on three of them: solution freezing point, solution boiling point, and solution vapor pressure. In the case of solution freezing point, the freezing point of a solution is always lower than the freezing point of the pure solvent. This phenomenon is known as freezing point depression. When you add something to the solvent, it depresses the freezing point. And you may be familiar with when cities put salt on the streets to melt snow or ice. What happens is when you put that salt on the ice or the snow, it lowers the freezing point of the salt-ice mixture, which makes it less likely to stay frozen at a lower temperature. So the solute in that case is the water from the ice or the snow, and it becomes a solution when you add that salt to it and lowers that freezing point. When we talk about solution boiling point, the boiling point of a solution is always higher than the boiling point of the pure solvent, and that phenomenon is called boiling point elevation. So adding something to the solvent causes the boiling point to become elevated or increased. And an example of that, well, you may be thinking about adding salt to, say, pasta water to make it boil faster. That's not really true. That when you add just a very small amount of salt like that, it's not really going to have an effect on the boiling point. It's really just being added for flavor. Now, if you add a ton of salt, it will add the boiling point, but it will also take longer to get that water to a boil because you've increased the boiling point. Plus, I'm not sure you'd want to eat the pasta if it had a ton of salt in it. So just use what you need for flavoring. But where this is true is when you have candy, when you're making candy and you have mixtures of sugar and water in a candy recipe, and the boiling point of those can be as high as 150 degrees C. Remember that water boils at 100 degrees C, so by adding large amounts of sugar to the water, you cause the boiling point to increase a great deal. The other property that we want to talk about is solution vapor pressure. So every liquid, and even solids, have molecules that escape into the gas phase. If you have a puddle of water, there are molecules of water in the gas phase just above the surface of the puddle. Water can evaporate even when it is well below its boiling point. And what vapor pressure is the maximum pressure of the compound in the gas phase above that liquid. We can measure that amount of pressure generated in a sealed container. So if you look, here is my sealed container with the little gas particles above the surface of the liquid. We aren't going to spend a whole lot of time talking about vapor pressure and dealing with that whole concept, but if you go on to AP Chemistry, you'll discuss it more. But what happens here, we're going to just deal with things that don't evaporate easily, things like salt. You have molecules escaping into the gas phase. If you add a solute to your solvent, then you're going to have fewer gas particles. You can even see in my illustration here of my solution that you have fewer gas particles escaping, and so the vapor pressure of a solvent in a solution is always lower than for the pure solvent. So the vapor pressure of the solution is the solvent in that solution is going to be lower than if it were just the pure solvent. You have fewer molecules escaping into that gas phase. One other thing we need to consider, remember that we said that colligative properties only depend on the number of particles in the solution. They don't depend on what the particles are. We need to think about the effect of the number of particles, the concentration. So if you have a 0.1 molar sucrose solution, the freezing point of that solution is the same as 0.1 molar glucose solution. If you have a sucrose solution that is 0.2 molar, it would be the same as 0.1 molar sodium chloride. Now think about why that might occur. If you have sodium chloride, it is an ionic compound. And remember that when we put it into water, it dissociates or breaks apart into sodium and chloride ions. Now you have twice as many particles as you do the sucrose molecules. Remember that molecule is an individual unit. And you also can have the same situation if you have a 0.3 molar sucrose solution. The freezing point of that would be the same as a 0.1 molar solution of calcium chloride. And the situation there, calcium chloride, remember the formula is CaCl2. And when that goes into water, it dissociates into calcium 2 plus ions. Calcium 2 plus ions and 2 Cl minus ions. So now you have 3 particles for each formula unit of calcium chloride, but each sucrose molecule is just one individual particle. So one way that this can be useful is if you add calcium chloride to the salt solution that you're using to spray on the roads, then that can cause more of the ice to melt. And I think probably less here maybe than in northern states, but they may use more calcium chloride when the temperatures are lower to increase the amount of ice that's melting on the roads to keep the roads safe.